So please let me know if you could see my screen. Yeah, so this was the link that I have shared you in the chat. Yeah, and then one more important information. So this batch will be starting on Saturday, which is I believe 25th, if I'm not wrong. Yeah. So this will be starting on Saturday 25th. More information about the batch, you can talk to the backend team. So this is where you can take a look at the uh, lab topology. So how was the lab gonna look like, especially for Palo Alto? And this is the curriculum. So if you just expand over the specific module, you will get to know what topics under that module you will be covering. Yeah. So that's your syllabus for Palo Alto. And let's move along to start with our session. The first agenda for today, where we'll be talking about what is a fire. I hope everyone are from a security background already. If they are not, this specific topic is just for them. So if you guys have already worked on routers and switches, if you have had experience working on not Cisco or any other vendor routers and switches, you probably might know what a router or a switch would do. But if you are not used to working on a firewall, that's where I'm going to come at to explain what a firewall or how a firewall is different from a standard router or a switch or basically a router. Yeah. So we're going to just differentiate a router from a firewall. Just we're going to start talk about the differences in short, and then we'll jump into the firewall world, and we'll talk about Palo Alto as a product in general. Yeah. Just give me 1 second. Yeah. Just give me a buzz if you could see my blackboard fine, so that I can get started, and if my voice is clear and loud. So just give me a thumbs up or give me a quick answer in the chat so that I can go ahead. I hope I'm audible and my screen is visible for you guys. So with that, let's get started. So yeah, to start with, let's just talk about a router and a firewall. So when I talk about a router, as you know, a router is a layer 3 device, which means it works on a network layer. And a router does routing, which means it is capable or responsible for carrying a packet, network packet, a layer 3 packet from one device to another device or from source to destination, basically. So it's basically supposed to route the traffic to the next available device, which can take the traffic from the source to destination. Yeah. So it could do routing. Yeah. So can a router do security? Yes, it can do security to some extent. So in a form of an access list, right? So we can define something called as an access list for security, for restricting or allowing or denying traffic from a source to a destination or to a destination itself, or whatever we could do with the access list, as you might have already seen what an access list could do, right? So this is what a router could basically do. We could do a lot of route manipulation and stuff that will come under routing, but a router can do only this much, and it couldn't do anything other than this intelligently to secure your network. Yeah. So that's the reason why we move towards firewall. And this is the purpose of actually talking about this topic. Yeah. So I would like you to know what a router could do and what are the limitations of it and how it is overcome by a firewall. Yeah. Especially a next gen firewall and VFW. Yeah. So let's talk about the similarities of a router and a firewall. So whatever a router is capable of doing over here, a firewall also should be able to do that, right? So router can do it, is a layer 3 device. A firewall as well is a layer 3 network layer device. It works on a layer 3 or network layer. Similar to a router, a firewall also can do routing. Because it's a layer 3 device, it could also perform different routing. I mean, it can also work with the different routing protocols to do routing. And it can also do security, not just with an access list, but you could configure something called as a security policy. And it is not just a device which allows or denies the traffic from a source to destination, but it could do much more. For example, when I talk about a router's access list for security, it can only do or it can only work with an access list or permit or deny traffic based on IP addresses, right? IP address of the network. Whereas a router or sorry, a firewall could do the same by restricting the user or restricting any network from accessing any network with the help of the application itself, whichever application the user accesses or whichever URL that the user tries to reach. For example, on onlinebo.com.eu or youtube.com or netflix.com or whatever URL it is, based on the application or based on the URL, etc., the firewall can inspect and allow or deny traffic based on our policy, right? It just doesn't stop there. It could do much more than this, which we will be talking about inside the session, probably not today. Yeah. So that's your difference between a router and a next generation firewall. Yeah. Along with this, there is one more factor that we need to talk about, which a router is not capable of, which is nothing but stateful inspection. All right. So let's just move down to talk about this specific feature called stateful inspection. So in general, next generation firewall is not going to allow anything by default. For instance, if I need to go from my local LAN network where I have a firewall, and if I have to need to go to somewhere in internet, the firewall here is not going to let the traffic go. It's going to block it by default. Or if anyone from internet wants to access my LAN, it is also going to be blocked by default. So nothing is allowed by the firewall by default without having us configure something, right? So we had to configure a policy to allow our traffic from one zone, for example, to another zone. So we'll talk about what is a zone extensively later on inside our session from Saturday. But consider a zone is nothing but a collective area where a group of networks reside. For example, when you talk about inside users, it could be a Wi-Fi user, it could be a guest user, it could be a LAN user, a cable user, I mean user who's connected through a cable, or Wi-Fi, or guest user, or a lab user, right? I mean where they do some testing or verification. So all these users are nothing but they are normal users, right? When they want to reach internet, they had to have a policy to be able to access to internet, able to grant access to internet. So we can all group all of them in a zone called inside zone probably. So I could use this zone in the policy and say from inside zone to outside zone, I can allow the traffic to internet. So zone is nothing but a group of networks or group of interfaces or group of networks. So understand it that way. We'll talk about zones in extensive manner inside our session on from Saturday this week. Yeah. So let's talk about stateful inspection. Let's come back to this one. So let's, for example, consider a user wants to reach a website in internet called youtube.com, right? So as I mentioned, there is nothing that a firewall allows by default, right? You got to have everything defined under a policy for a user to access anything from one network to another network. Yeah. So nothing is allowed by default by the firewall, right? So you got to you understand that for a user from inside his LAN network to reach youtube.com in internet, there should be a policy that you need to define because nothing is allowed by default. You could say that from inside to outside to access youtube.com, I'm allowing the traffic. So I got to define something like this for me to allow the traffic to internet. Okay. So let's just understand a bit about how the traffic flow happens here. So when a user, let me draw this again, user firewall YouTube, right? So we have a policy here, as I mentioned above. Policy is this one. So when a user accesses the traffic, the user will try to hit youtube.com, and the firewall here sitting in the middle will look at the policy. It sees that the policy says that inside to outside for youtube.com is allowed. It will allow the traffic. Additionally, it's going to create a session stating that source is this, destination is this, and the protocol is this, which is nothing but HTTPS, because we are accessing HTTPS youtube.com, and the traffic is allowed. Okay, so it will create a session. And when the return traffic, when the youtube.com responds back, that's when you get the page here when you type youtube.com and you get a page, right? So you get a page when youtube.com responds back, and the response gets received onto your user's PC. And when the response comes back, the firewall is going to automatically allow the return traffic without a policy. So if you see here, the policy is only talking about one-way flow. It's talking about the flow from user to the server, not the server to the user. So when one end of the session is allowed by the firewall, the same session's return traffic is automatically allowed by the firewall. So you should understand, it's not that the youtube.com is initiating the traffic here, it is just responding to the traffic initiated by the user. So user is sending a traffic to access youtube.com, and that session is responded by youtube.com back to the user. So since the firewall is having a note of a session for the forward traffic, this is the forward traffic, this is the reverse traffic. So this is a response, this is the request, or you could say this is a request, this is the response. So for the request, you already have a policy, and the firewall is maintaining a session for that. And with the help of that session, when the response traffic comes back for the same session that the firewall is keeping track of, the firewall is going to allow that by default. So this way of allowing the return traffic or response traffic without a policy is called as stateful inspection. So basically, the firewall is inspecting the connection using a session table. Hence, the return traffic is allowed by default with the help of this session inspection, right? So this feature of stateful inspection is not by default available on a router. So firewall is different in that way. Yeah. So that's what we call it as a stateful inspection. This is one important thing that you probably would get as a question in your interviews. If not, this is one important thing that you should remember. You do not really need to configure a policy for the reverse or response traffic. Only forward or request, the traffic for the request needs a policy, not the response, right? Because the firewall is stateful inspection based firewall. Okay, I hope this is clear. Okay, let's first try to talk a little bit about the features of Palo Alto, and then we'll move on to the lab to demonstrate how the firewall looks like, how the dashboard overview looks like, and we'll do a short lab on some other topic as well. Okay, so if we talk about the features, first thing, the firewall is a stateful inspection firewall. We spoke about what is a stateful inspection. It has a feature called as a user ID. I'll just list down a few features, and we'll talk about it in brief once I list them down. Okay, these are not only the features that the firewall possesses, but I'm just not dropping them down. Whatever comes to my mind on top of my mind. Yeah. So there are a few other features which we'll talk about inside the session. So stay tuned for that. So stateful inspection is one thing that we already spoke about. User ID, and we have something called as wildfire. That is another feature. And as usual, any other next generation firewall could do. We also have antivirus, malware, anti-malware, spyware, file blocking, etc. Um, what else? We also can talk about virtual router. That is again another feature. It's not a security feature, by the way, but it's again another feature by Palo Alto. Um, we also can talk about App ID, which is very, very important. URL filtering. Yeah, I hope this should be sufficient for today. Okay, stateful inspection is already done. User ID. So I hope you guys are aware of something called as LDAP profile, Active Directory, where we will maintain the username to IP mapping, right? So when a user joins a domain, your company's domain network, and he gets an IP address, the username to IP address mapping is saved under your LDAP, under your Active Directory using your LDAP protocol. Yeah. So this username to IP mapping can be integrated with your firewall, right? Using some configuration. So this, after this integration happens, this username to IP mapping directory or this database information can be available on your firewall, where your firewall will then be able to, as an administrator, you will then be able to create policies using your username, right? You can say that instead of saying for this network, allow youtube.com, you can say under this network for this specific user or user group, allow this youtube.com. Yeah. So we could also be able to control the traffic based on, not only based on network, but also based on usernames and user groups, right? And eventually we can also view the traffic logs based on the username as to which user has access to which traffic. Yeah. So that's called as user ID. We will talk much more about this inside the session. We'll talk about wildfire. So wildfire is a very critical feature, a very cool feature, I would say, yet very important, where if an organization experiences a zero-day attack, for example, if it's an attack which is experienced for the first time um, in the cybersecurity industry, let's say, for example, a user is trying to reach a server and there's a firewall in the middle. And if a user downloads a specific file, which is a malicious file, which is something that is not being tracked as a threat before by the firewall allows this file to be downloaded and this PC gets infected and everything is happening. This firewall silently watches this. And if this firewall finds this to be fishy, but doesn't know if it's a threat or not, what it does is it sends this specific traffic. The verdict of this traffic is sent to the sandbox, which is nothing but your Palo Alto cloud. Inside your Palo Alto cloud, you'll have a test environment. So to send it to the test environment, and this sandbox is nothing but a computer, it's a test computer. It will access this server like a user and get the fishy file that the user downloaded earlier, and it will analyze that file to see if it's a threat file or not. If it's identified to be a threat, the sandbox will let the Palo Alto cloud know about it. And PA Cloud will then send this information to all the firewalls which has the wildfire license. So this happens within 5 minutes of identifying the threat, right? So if any firewall, if any organization doesn't have a wildfire license, considering the cost, if they have threat license, so if they only have something called as a threat license, they can get the same information within 24 hours time. So, however, if to the minimum, if you have a threat license for a firewall, if there is a zero-day attack, and if that attack is identified to be a threat, then your Palo Alto Cloud will take responsibility of letting everyone else in the world who has the threat license or wildfire license to make sure that they're aware of this activity within 5 minutes or 24 hours, depending on what license do you have. Okay, so that's your wildfire. And I hope antivirus, anti-malware, spyware is all something that you guys have already went through. We will talk much more about it inside the session. We'll move on to the next one. This is called as VR. So if you guys have worked in a Cisco environment, you might have already heard about something called as uh, VRF, virtual routing and forwarding, which is nothing but dividing your routing instance of one router. So for a single router, you will have one routing instance, default routing instance, right? So if you say show IP route on your Cisco router, you will get a routing table, which is a default routing table for your router. So likewise, your Palo Alto firewall will have a default virtual router via VR called default, which is nothing but your default virtual router. But you're also it's also possible for you to create multiple virtual routers called as it's nothing but multiple VRFs for you to divide the routing instance into multiple ones, right? So you can just divide, you can put multiple interfaces onto each routing instance and you can control the routing for each of these interfaces separately. Yeah. So probably we can also do a lab on this one later on. For now, I would expect you to understand what a VR is. Yeah. So the next one up is app ID and URL filtering. So let's talk about. Okay. Let's talk about app ID. So as I mentioned earlier, application ID is nothing but it's a feature where if a user accesses facebook.com, just think about this. Let's say he's accessing this using a browser. So just think about what all protocols this traffic might have involved itself into. So first, when a user accesses anything inside a browser, he would use HTTPS. So the protocol used here is nothing but SSL, right? So this is the first protocol used. And when he accesses a website inside it called facebook.com, and as soon as the firewall knows that it's facebook.com website, and once he logs in, the firewall would identify this to be is Facebook. And within Facebook website, if he accesses Facebook chat or video, etc., so right from the beginning of this session, where the user accesses https facebook.com, the application is identified to be SSL. And once he logs in, it is identified as Facebook. And once he gets into chat with someone or video or any other no, tab inside Facebook, the application is identified to be exactly what the user is actually doing inside the application. So the app ID feature is capable of identifying the end application that the user is using inside his session. Yeah. So the application is divided into multiple categories, and also it is divided into multiple uh, risk factors. So if it is highly risky, it will be risk factor number 1, 2, 3, and 4. It is categorized based on risk as well as based on the category. For example, gaming, social media, uh, or entertainment, etc. Right? So based on the category, you can say that I'm allowing this specific applications. Based on gaming category, I'm allowing everything. Based on social media category, I'm allowing everything. So you can allow the traffic based on a single application like SSL, Facebook, YouTube, Ping, etc. Or you could allow the traffic based on the category wise as well. Okay. So that's your app ID feature. Similarly, URL filtering. Again, it's a feature where a URL is categorized based on the category called gaming or social media or entertainment. So if I can just go to URL categories here, or I could go for this website, test a site. So I can just probably give any website here. Let me say youtube.com, and I just acknowledge this and I say search. This is going to give me what category and what risk level it belongs to. So similarly, it is similar for applications as well. For URLs, if you see, if I just type in youtube.com, I can see that it is based on the category streaming media and the risk level is low, which means it's safe to use. Yeah. And it's also giving a description on what is streaming media and what is low risk level sites, and example of a few of the low risk level sites as well. And likewise, Palo Alto dynamically categorizes the URLs based on their category and risk level. All right. So yeah, that's about in short about how a Palo Alto feature can be dealt with. We have a lot more features to talk about. But for now, we'll stop here for the features. We'll just get into the grooves of handling the firewall. I'll also talk a bit about the packet flow before we get started with some short lab demonstration. So this is your website, which you can go through for understanding the firewall's packet flow. Let me talk a little bit about it, probably not in detail, but I'll just go over in short about the packet flow. So if you see, there are about 5 phases that you need to deal with respect to your firewall's packet flow. One is ingress, another one is egress. As you know, ingress means when the traffic enters inside, what happens, and just before the traffic exits the firewall, what exactly happens to the firewall. And in between that, you have firewall session setup or slow path or fast path. You have application ID and content inspection. So let's quickly go over this uh, 5 stages. So if you see the ingress stage, it's very simple. It extracts some basic information layer 2, layer 3, layer 4, and it checks if there is any error in processing these layer 3 to layer 4 information. If yes, it discards it. If not, it checks if the firewall is uh, capable for session inspection. So how does it identify if the firewall is capable of inspection or not? If the firewall has to inspect the session or not? It checks the table basically. So if it's a layer 3 um, unicast, it can inspect and forward. If it's layer 3 broadcast, it will drop because layer 3 doesn't do broadcast at all. If you're aware of how a layer 3 device works, it stops broadcast right there, right? So depending upon what is the type of the interface and what type of packet it is, it will decide whether to inspect that packet or not. Yeah. And it checks if it's a VPN tunnel. If it's a VPN tunnel, it's going to decrypt the VPN tunnel to check the inside header, and it does the same thing all over again. Yeah. And then when it comes out of ingress stage, if it checks if the session is already present for the source and destination and for this protocol or port number. If the session is already available, it directly goes to fastpath. You see, it checks for the session lookup. Okay, if it also already has session match found, for example, I'm trying to access youtube.com, and if I have already accessed youtube.com half an hour before, that session is already going to be available on my firewall. Hence, the firewall will not go over the slow path, which means the slow path is basically for forming a session if it's a new connection that's made by the user for a specific website that is trying to reach, for example. Okay, so if the session is already available, it's not going to go to the slow path. If it's a new session, it's going to come to the slow path and it's going to do a forwarding lookup. It checks the routing. It's going to check the NAT available source to destination traffic is capable of having a NAT policy, if it has a NAT policy or not. And it also checks the security policy. And while checking the security policy, for the source IP, destination IP, for the protocol port number, etc. It keeps the application as any here and checks for the other parameters if it's allowed or not. Because if you see, the application identification happens here on the firewall packet flow. So at this point of time, the application is unknown. The user or the firewall doesn't know what's the application that the user is accessing. So it cannot inspect, it cannot check it across the security policy lookup. So hence, it checks all the other parameters. It keeps the application as any at this point of time, right? And once the rule match is found, it creates and installs a session. Okay. And then it comes to this fast path where it executes the NAT, right? It executes the NAT here, and it also does decryption if applicable. So if I forgot to tell you that the firewall is also capable of doing SSL or SSH inspection. Basically, it's capable of performing decryption, where if it's an SSL packet, if it's a HTTPS packet, it is all encrypted, right? So it cannot be, it's not visible for everyone outside. It's encrypted. So if you want to see what's inside an encrypted packet, you could create a policy and say that I want to decrypt this one, right? So firewall is also capable of decrypting an encrypted SSL or SSH packet. Okay, it checks if there is any SSH or SSL encryption, decryption policy available for us to decrypt the packet. If not, it goes down. It parallelly does two things. One, it identifies the application based on the pattern of the application, and it checks across the security policy. So if you see the security policy lookup here, it's happening without the application check. It keeps application as any. So after it is identified the application, it will then do a security policy lookup again to check for the rule match. And parallelly, it is going to do antivirus, anti-malware, and all the profile checks to see if the packet is allowed for forwarding it to the next stage, to the next device or not, or if it is supposed to be dropped. At the end here, if the SSL decryption has happened earlier, here it is supposed to re-encrypt the packet if the decryption has happened earlier. Yeah. And finally, it's going to send out the packet to the egress stage. And if I would have done the IPsec, if I would have inspected the IPsec packet here, I would have done a tunnel decryption here where I need to do a encryption back again to send the packet outside. So if it was a tunnel packet and if I would have done a decryption at the ingress stage, I'm supposed to do a re-encryption here and then send the traffic out to the next device from the firewall. Okay, so this is how, in short, the firewall processes the traffic from the time it receives the traffic to the time it sends it out. Yeah. So yeah, as I said, we'll extensively talk about it because there are some caveats which we need to talk about with respect to the NAT policy lookup, how in detail it looks up the NAT policy. No, I'll talk about all of that inside the session exclusively. Yeah. So for now, I hope you've got an idea on how the packet is processed. Okay, so this is how your lab is going to look like. And if this is no too overwhelming, I'll go with a much shorter lab. But there'll not be any compromise on the topics covered. But then yeah, so this is the platform that we'll be using for the lab. So let me just power on the firewall to show you how the dashboard looks like to close up the session. Just give me one moment for me to open this firewall up. Okay, so I will talk about how the firewall got the IP automatically here. If you have not used EVNG platform or Peanut Lab platform, you might not have an idea about this. But then I basically have connected my management network to my local management interface of my firewall to the local network. So that's how I get an IP address from the local machine, and I can access it, from my browser itself directly. That's for that's for later for us to discuss. But for now, I'm just accessing the firewall. So by default, the username and password for the firewall would be admin and admin when it's first out of the box, and it's going to ask you to change the password. I'm going to change the password to a different one. So I type admin and admin, and the old password is admin. The new password, I'm giving the new password, a new one, confirming the same. And now it's going to let me in. So this is your firewall interface. Let's not get into the CLI for now. I'm just going to log in using the GUI to show you the dashboard overview. Okay. So these are all the tabs that you will probably see when you log into the firewall. Let me try to explain this in short on what are they. So dashboard will give you some basic information about the device, for example, about your device name, serial number, your license information, your management IP address and the network, your model number, your host name, and time of the device, and how long the device is up and running and stuff like that, and the management CPU and data plane CPU, and how many sessions are currently active on the firewall, and who has logged into the device, and system logs, what exactly is happening to the device. So if you see user admin logged in via web using the IP address with HTTPS protocol. So whatever is happening to the firewall will be notified here. So if you see, I've done one failed authentication using the username admin. So all the happenings inside the device will be over here. So that's your dashboard. ACC, I personally do not use this unless and until I need some reports to be submitted from management. But otherwise, this is nothing but some graphical representation of what you will see under monitor tab. Yeah. So whatever you will see under monitor tab as a log, you will see them under ACC tab as a graph. Yeah, that's how I understand this. Yeah. So you could browse through the tab, different tabs available here to understand what are they. Now it is self-explanatory as it's a graphical representation. So you can go through this to get familiarity. Let's move on to the monitor tab where you will have much of the work to do if you're not working under BAU support. So this is where your users traffic would come and hit. You will have all the logs available here in a traffic log and threat log, URL filtering log. These are all separately for different services with the firewall office. This is for threat, this is for URL filtering, wildfire, this is for global protect, this is a solution for remote access, user ID, decryption. So all these features I think we have spoken about just now under the features of Palo Alto. So system logs, this is the same system log that we saw on the dashboard. So that is the widget over here. This is the same log that we seeing under this monitor system tab, right? So if you see the same stuff will be over here, authenticated for user admin, failed authentication, yeah. So otherwise, these are generating reports. This is a session browser. So as I mentioned, every traffic that goes to the firewall will maintain a session table. Okay, this is the session table I'm talking about. Yeah. So once the session is complete, so if you're talking about a TCP session, if the TCP session is completely formed, if the three-way handshake completes, only then your traffic will be available into the traffic log. Yeah, you got to understand that. Okay, that's about your monitor tab. It's coming on to the policies tab. You will have all of the security policy, NAT policy, decryption policy, policy-based forwarding, QoS policy, and all the related policies will be available here for you to configure. And objects tab, you will have all your application objects, address objects, your address groups, grouping different address objects together, service groups, service objects. You have all your security profiles. As I mentioned, antivirus, spyware, vulnerability, URL filtering, file blocking, all those stuffs are here. And under network tab, you'll have all your routing, IPsec, VPN, DNS, DHCP. The routing configurations are all supposed to be configured over here, right? So going to device tab, everything related to the device. For example, if you want to configure the management interface, if you want to take backup, if you want to configure a high availability for your device, if you want to create a user for your device to access your device, or if you would like to configure certificates, or if you want to configure syslog and any other services for your device, everything would be over here for you to configure. So anything for the device is under this. Anything for the user would be under these three tabs, right? So that's pretty much about the firewall overview. So rest, I think we could probably uh, deal with it on our Saturday session. I hope you've got a brief idea about what a Palo Alto firewall is and how it works and why are we using them in the first place. Everything related to the demonstration, practical understanding will be exclusively from Saturday. So you can contact the backend team for you to have more information about it. And as I mentioned, you can go over the website that I've shared you for you to understand the syllabus, and you can contact the backend team for more information. Okay. Yeah, that's the session. That's about the session in short. If you guys have any questions, you could let me know. If not, I'll let the
Yeah,
person
hi
talk
Azhar.
about further
Yeah,
proceedings here. Yeah, Sajid, can you take over?
yeah, I will take it from here. Thank you.
All right, thank you.
Yeah, hello Carlos and Rakesh. Sajid this side from Network Journey Training Institute. So I am student relationship manager in the counselor. So I'm here to give you details regarding this Palo Alto course and Fortigate course and Cisco ASA and Checkpoint and FIL team load balancer. So overall, this will be a firewall training. Okay, multi-vendor. Yeah. So let me start with my first slide. So as you can see here, so I have mentioned details for firewall mastery 3-in-1 combo course, which covers Palo Alto firewall. So in Palo Alto, we are covering PCNSA, PCNSA, and in Fortigate, we'll be covering NSE4 and NSE7, and there will be the Cisco ASA FTD, okay, which is Cisco firewall, so which covers ASA, FTD, FMC. So all these things will be covered here, okay. And here this will be going to be a weekend batch, So as you can see here, I have mentioned details for the course schedule. So this will be a weekend batch, Saturday and Sunday. So from the morning 9 a.m. to 11 a.m. IST. Okay, every day 2 hours of session on Saturday and Sunday, and the overall course duration will comes up for 3 to 4 months. Okay, and let me move towards my next slide. So as you can see here, so I have mentioned details for course enrollment and access detail. What all access you'll be getting once you are going to enroll for this course. So you'll be getting the recording access that remains with you for lifetime. There you will be getting actual live class recorded version, means what all live classes you'll be attending, that recordings you'll be getting on your portal, so that in future if you want to go through the videos, if you want to practice something, you can go through that, and that will remain there for lifetime accessible. And secondly, we are providing you the three months of remote lab access, that you can access it totally remotely, 24 into 7, unlimited. Whenever you want, you can access it. Okay. For PaloAlto 3 months, for Fortigate 3 months, for ESAFTD 3 months. So overall, total 9 months of lab access you'll be getting, and you'll be getting and dedicated materials like workbooks, PPTs, PDFs, step-by-step lab manuals, all the reading materials. Everything will be provided from our side, so you can download and you can keep it with you as well. And the G Drive access remains with you for lifetime. If in case if you missed out any material, you can re-download it once again. And we'll be assisting you for the home lab setup too. Let's say if you have the good configuration of your system, then we'll be helping you to set up a home lab, so that once you are done with your remote lab access, or simultaneously you can have a practice on your system too. So you can have the setup on your system. It may be on your system or it may be on your server. So we'll be helping you out. Okay, and that will also remain with you for lifetime accessible. Whenever you want, you can access it on your machine till you have it on your site. Okay, and for that setup you just require to download the files from our Z drive. So after download, so one of our team member will connect with you, and will be doing the setup on your system. Okay, and we'll be providing you the 24 into 7 backend support from our team. If you are facing any issues, any queries regarding to the course, or regarding to the portal, or regarding to the lab, or it may be related to anything, you just need to raise a ticket on our support DL. One of our team member will connect with you, and we will resolve your issues accordingly in meantime. Okay. Yeah. So these all access and materials you'll be getting once you are